Hey everyone, welcome to another Unreal video. In this video we're going to take this thing that we built last time and we're going to implement it. So let's get started. So we have this behavior tree. It's pretty boring because there's nothing in it whatsoever. The first thing that we want to do, if we go back to our little image here, is we want some kind of selector. And this selector is going to have a service on it. So that's simple enough, selector. And then this selector will put our own service on it. We're going to kind of ignore that for now and look down here and see, well, what else do we need? We need to be able to see whether or not we have a target. And if we do have a target, then, we need to see how spotted we are. And down here, we have our sort of relaxed state as well. So what do I mean by finding a target? What does that really mean? For our purposes, finding a target means that this AI is going to do whatever its kind of perception update is and see if it can detect the player. And we want a bunch of different things. So let's take a look at this guy here. This guy's just facing sort of up based on how I have him viewed. So what I want to do is, let's talk about different ways of sensing. So one way of sensing is with some kind of vision cone. And there's a lot of ways that you can do this. See if I can do this a little more competently. So one way is to have an actual cone. And a lot of times you actually kind of surround the character. So it's like, you surround this way and it might be, this is maybe a smaller cone than I would use, but you get the idea. Like an actual literal cone. Another version of this is you could actually do kind of a wide cone to model peripheral vision. So you have something like this. And maybe this is one version. And then here, usually, here, let me redo this. Usually at around 60 degrees or so, like a 60-degree angle, you might have kind of an extra wide or extra long spot like this. This is kind of to model, let's see if I can find it. This is to model human vision cones, basically, like how humans actually look at the world. In fact, yeah, this one is really good because we can see our comfort zone, our area of focus is about 60 degrees. At about 30 degrees, we have symbol recognition, so glyphs, characters and symbols like words and things like that. We have peripheral vision at 30 degrees on either side, and monocular and so on. And it goes out to about, this sort of 110, so 220 total angle of any vision whatsoever. And so we can kind of model that a little bit right here, if we want to. Other things that we can do are we can model sound. The easiest way to model sound is to just have some radius that if a sound producing thing happens, this character might notice it, and it could be based on the strength of the sound or any of those types of things. You can have touch, which if you collide with the character, he has some collision volume around him, so if you collide with him, then he should definitely know. You may have other things, smell, or even like smells. It could be a good one if there's fire or something like that. You might have that kind of stuff. But another one that I like to include, if I am generally close enough, then maybe there's almost a sixth sense that they notice you. And it always depends on the game, but in any kind of like action game, a lot of times this can feel wrong. If you do your sound stuff right, it can be better, but there is kind of such a thing. If I have a human being that's here, there actually is this concept of like a personal bubble around them. And this gets really interesting because it's different in different cultures. Here, in our kind of Western culture, that bubble tends to be fairly large. In many other cultures, it is not. It's much smaller. Right. I don't think I'm going to go for this like massive vision cone or any of that kind of stuff. I think we would just bog ourselves down in doing that. So what I want to do is I want to basically do a more simple yet still powerful, it's called a sphere test. So you'll see what it looks like. So we have our little behavior tree here. with our one selector. And so what we want to do is we want to add a service. And so I'm going to go here and I'm going to create a little folder under AI called, custom nodes. Just, this seems like the right thing to do. In fact, I might rename this to, yeah, why don't we do that? Why don't we create this folder called services, and we'll have one for all the different things. Here in services, we're going to create a new thing. It's sadly not under artificial intelligence or really anything. I don't think it's under any of these. So we have to go and basically say new blueprint class and then dig in here to all classes and find the thing. So in our case, it's service. Here it is, service blueprint base, select, and we built one of these already. I'm gonna say, I'm gonna say find target. Here's our find target service. The first thing we're gonna do is we're gonna do our event receive, here it is, receive tick AI. So that's our first thing. So we're gonna do two different kinds of senses. We're gonna do sight and we're gonna do hearing. And I think for our little game, our little stealth thing, I think that's the right call. So what these are gonna do is if any of these kind of tests, if the sight test or anything pass, it's gonna set a target. By virtue of having a target, it means the AI is triggered in some way. It says, oh, I have a target, I better deal with that target. So that's the first thing that we want to do here. I'm going to step back out here to our blackboard. The blackboard's going to contain all this stuff. So here I'm going to say new key. The key that I want is an object type, and I'm going to just call it target. I could say target actor or something. So target. And so this is our target that we want to basically attack. It's of type object. And we don't want to necessarily sync it. We can use a specific base class if we want to. I just hit this little triangle to expand this out. Here, I'll zoom this in a little bit. So we can expand it if we want to. I literally just hit this little guy. So this object, I can search for a thing that I want, and I can say first person character. This is our first person character that we actually control. This is the player. So I could just do this, and now it has to be that. I'm not convinced that that's what I want to do. So I'm gonna reset this so it's just an object. But it's something you could do to limit it more. The reason I'm not convinced that it's the right thing to do is because you may want to set up a thing where they attack, objects in the game that are not necessarily the player. So the player may have pets that you might want them to attack each other. So I'm going to leave this as object right now. A character might be reasonable, but it's a thing that you can do here. So that's what we've got for this. If I zoom this guy back out, here's our little blackboard guy. Now, normally we would want to go back out here to our Hunter AI controller and add a little thing in here that initializes it. But for object types like this, they auto-initialize to null. So because of that, we don't really have to do anything particularly special here. We just let it do its thing. Okay, so back to our find target event. Let's talk about what we really want to do. So there's going to be 3 stages to this. Let's kind of step back out here, and I'm going to give another example with, one of these guys. We'll use this guy. He seems fine. So what I want to do, I'll hover right over him. We can see that he's basically pointing up. So what we're going to do is, this is what we're actually going to do. We're going to have a few stages. Stage number 1, so one thing we want to do is we want to draw a raycast from this point to the player, right, wherever the player is, and see, are we actually facing them in some way? Like, are we generally facing them? We want to do a basic radius test around here to see, can I hear you? Now, there's kind of an issue with this. We could just do this, and this would work, but there's a bit of an issue. And this may get a little programmery. I'm going to go to my little programmer corner over here. I'm going to briefly talk about this issue. So the problem is, how many enemies do I have in the world? Maybe 15, 20? We're going to do a bunch of raycasts. So to make this all computer science-y, if we say that we have n enemies, right? We have some number of enemies, then the growth rate of, like, the number of raycasts that we do is also equal to n. So in other words, as n goes up, as we add more enemies, we have more raycasts that are happening, potentially all at the same time. Hopefully not. In programmer terms, this makes it a linear or big O of n operation. And that's not a huge deal, but it can be when you're doing things like raycasts, which are really slow. So we want to do something, we can limit the number of raycasts that we do when we want to limit the number of raycasts that we do. Technically, it's still big O of n if you want to get pedantic about it, but it works. It will generally lower this value. So what do? We do this. As a first pass, I am going to basically, oops, let's see if I can do this a little better. I'm going to do this like kind of multi-sphere test. Unreal lets you do this kind of ovoid shape like this. So I'm going to do this. If the player is within this sort of multi-sphere hull that I'm creating, then we'll do the raycast. And especially with how I have my level laid out, the chances that you're going to be in two people's hulls at the same time, that can be somewhat likely. The chances that you're going to be in three people's hulls, pretty unlikely. In fact, most of the time, you're not going to be in anybody's hull, right? And most of the time, the player will be out here somewhere, and they're not going to be in this at all. So we're doing one test and then bailing. And that's the idea. That's what we want. That's the goal. So the plan is to basically do that test, and if we pass the test, then keep doing the more like expensive stuff. If we fail the test, then we're done and we just bail. So that's the plan. Okay, let's actually start writing some of this stuff. So what I want to do is go to I have my target and all this other stuff. So I have all the stuff that I need to get started. Here in the find target function, or in the find target node, I'm going to add a new function that I'm going to call sphere test. This is our first test. I like to separate concepts. We have three core concepts. We have the sphere test, the raycast, and the sound test. I like to separate those into different functions. So here's our sphere test. It's going to need some stuff. We're going to need an input. I'm going to add in, as an input, the agent, and it's a pawn, so that's correct. For the output, what I'm going to do is add in something called hits, and it is specifically an array of hit results. These are our hit results. Now, and I'll zoom this in over here. The hit results, we want it to be an array. And so the way to do that is you hit this little kind of button here, and then you have all these options here. One of them is array. There's set, there's map. So there's different sort of data structures. We want array. So it's going to return an array of hits. That's what we want. And that array may be 0. So this is probably what we're going to need for these things. The next thing we want to do is basically we want to do the math. So the way that I'll tell you what, I'll do this. We'll set it up like this so that I do the multi-sphere trace for objects. This is all this stuff. This is good stuff to look at. We want multi-sphere trace for objects, which has all this stuff. And so I think the easiest way to look at this is to just kind of go through these parameters. Hits goes here. Oh, there's return value. Maybe I want to just return everything from here. I'm going to add a second result. We might not actually need this. Like hit anything. I think I'm going to do this. you are not a Boolean array, you're a regular Boolean, hit anything, and then I'll just pull this guy over here. That way it's just returning exactly what multi-sphere trace for objects returns. Okay, that feels better. So we need to calculate all this stuff. So it has a start point and an end point. And the way that that works is it creates a start, like if I go back to here, it's basically going to have a start, an end, and it's going to create a hull around a sphere, sort of a not spherical, but sort of an ovoid hull around those 2 points, as if these were the 2 centers of spheres. There's a radius, so the radius is effectively the radius of the sphere, of the 2 spheres. So like how far out, right? A smaller radius is gonna do, you know, this sort of thing. So how far out do you want it? There's a bunch of other stuff in here that we'll kind of look at. So let's kind of go through these. The first thing I want to do is I want to figure out the start and the end point. And we need to figure out what exactly that is. So this is where math comes into play. We essentially want to do, you know, if the enemy is here, we want to take the forward vector and its current position here. And so this forward vector is what's called a normalized vector. We can multiply that by some what's called scalar, some value, to get like some distance ahead. So in other words, if I have a character's position, which is this point here, right? And I want to say, let's look 10 units ahead of me. I could take the forward vector, multiply it by 10, and add that to this. So that would take this vector, make it long, like this, longer, and then we would just set that on top of this guy, and then here is a point 10 units ahead. So we're going to basically do that math. And personally, I kind of hate doing math in Blueprint. It's not super fun. So this is why we need the agent, because we need to do get actor, where are you? Get actor location. And we need to do, I'll pull this guy back. This is going to need to go kind of far back. Same thing, we need to do get actor, where are you? There you are, forward vector. So these are the two things. So forward vector is the actor's, basically a vector pointing forward from the actor's point of view. And it's normalized, which is really nice. Okay. So those are there, and so now we're going to, here, let me pull this guy down here. So this is the start location. I guess I didn't need to pull these guys out this much. This is the start location, the actor's current position. The end location is essentially the actor's forward vector multiplied by some distance. So what distance is that? Well, I don't know. Let's figure it out. Let's tune it. And so we want to change this to a float. This is our, I just said tuning. That's not what I wanted. I want sphere distance, and I want to put it in the tuning folder. You know, in some of this stuff, I'm going to try and instill some best practices. So best practice is to always have a tooltip, right? Distance. Distance from actor of the second, I should say not actor, I should say agent. Distance from the agent of the second sphere for the sphere test, or something like that. I'd probably come up with something better in a real project. So now we need to set a bunch of this stuff, right? And I always, whenever I create a new variable, I always try and like look at this stuff and say, what are the things that I need? So I know that I need it editable. Here, let me zoom in. I know I need it editable. It's not it's not Blueprint read only, although I suppose it could be. Expose on spawn, is it private? Yeah, it kind of is. Expose to cinematic, I don't care about that. It's in tuning. Do I want a specific range? Well, probably. Maybe I'll say 0 because it can't be negative. In fact, maybe it can't even be 0, so maybe we say it's at least 1 unit. Value range is 1. Maybe we do want to put a maximum, but for now I'm going to leave it here. Replication, I don't care, and I don't care about any of this stuff. So that's kind of what we have so far for this. I'll compile. Oh no, it doesn't want something. Oh, that's fine. We just haven't actually finished, so that's okay. So here's our sphere distance. This will be tuned. I want a default value. So my default value, oh, I don't know, 500 seems good. We'll use 500. I'm sure that's great. Okay, so sphere distance. Oh, and of course I don't want this. I want these guys multiplied. So it's going to be vector times float. And this guy goes here. And of course we don't want that. And then, as I said before, we want to add this guy with this guy. And then we want to pull this into end. So it's all this stuff. And this whole thing calculates the start and end points for the spheres. So let's pull this guy out here. Let's pull this guy out here. And let's comment and say, you know, calculate start and end points for spheres. There we go. So that's what this thing does. Next thing I want to do is we keep kind of going down here. So now we want to look at radius. Well, I think radius is basically the same thing. So let's add that, tuning, radius, and we'll pull this guy also in tuning. I'm not going to add a bunch of stuff, mostly for time restraints, but I am going to do this stuff. So we want to do these guys, and I'm not going to do any of that either. And then the radius is going to be, I don't know, 1500. That feels right. So we pull this radius over, and I'm going to pull these guys over as well. Because this whole thing is going to be this sort of calculation. Okay, so what about object types? You know, what desired object types do we want? Well, you know, once again, I think that the right thing to do is to do some kind of like this thing's going to want some kind of variable. That's the easiest way to do this. So I'm actually just going to like create this as a variable that I can kind of tune. I'm not going to put this into tuning. I'm going to put this in a new thing called internal. It's not meant to be tuned or edited in any way. It's meant to be entirely an internal thing. And I'm going to call this desired object types. So you have to tell it what types of things is it allowed to collide with. So that's what this is. That's the whole point of this piece of it. Okay. So desired object types. Oh, I have to compile this. We're gonna do a little add. Is this right? Yeah, this is right. So we're gonna do a little add, and we're gonna make it pawns. So it generally wants a pawn. All right. Do you still have a warning? Nope. Now we need actors to ignore. So this becomes interesting because this is every object that we want to ignore. So this is a little wonky. We can say we may need this in multiple places. So what we can do is we can create our own sort of array of things. Yeah, let's do that. So, you know, object types is what are the types of objects I can collide with. Objects to ignore will represent, so I have to change this to an array of objects. What do you want? You want actors. So you have to kind of match the type. So if you want actors, we'll do actor. And we'll change this so that it's an array. Do I want this editable? I don't think so. I think we'll calculate this ourselves. So objects to ignore, we'll add this right now. And we'll fill all this stuff out in a minute. Debug draw type. Okay, so here's another thing. Debug draw type is, you know, do I want to draw the debug data for never, for one frame for the duration, or make it persistent? Little spoiler, we're going to have a bunch of these types of rendering things. So what I'm actually going to do is I'm going to create yet another variable that I'm going to say debug draw. You know what this is? I'm not sure what this variable is, so I'm actually going to create it by doing this. This is sometimes easier. Promote to variable. There we go. Debug draw. If it's a debug configuration thing, I actually put it in its own little thing. So let's put this in a thing called debug. There we go. Do I want this tunable? I feel like I probably do, so that I can just edit it easily. Private and so on. So here's that, and that's going to go here. Oh, you're already there. So we'll drag you down here. And that's it. Do we want to ignore self? Absolutely. What trace colors do we want? We'll leave these default. These are fine. So this is it for our basic multi-sphere test. So I'm going to say, you know, sweep for objects, right? This is our first really basic pass. And literally all this is doing is returning this result. So that's all that's happening here. So there's a couple things that we still have to do. The first thing, well, one major thing that we still have to do. One big thing that we're missing right now. And the big thing that we're missing is we haven't set up this objects to ignore. So let's kind of review a little bit. This multi-sphere trace is going to create this like ovoid shape, and you'll see it in a minute. It's going to use the start and end locations. Like this is sort of its location. So its start location is wherever the actor is. Its end location is some distance, some tunable distance ahead of the actor. And this math lets us say this is, you know, this sphere distance. So it's going to be 500 units ahead of the actor, ahead of the agent. This radius is how big do we want it, and so we want it 1500. That's what we've chosen. Object types is these are the types of objects that are valid to be traced. So it's going to ignore all the static objects, for instance, all the world objects. This is a list of this will be pawns specifically. It's actors, but we just need to put pawns in here. Anything that this guy could catch, because remember this guy is all pawns right now, or yeah, this guy is all pawns. See pawn. Object to ignore, we have to put a list of pawns that I want to ignore. Debug draw is whether or not we're going to draw what's happening. And right now, let's compile this. I'm going to default debug draw to persistent so we can watch it. So let's do this. Let's set all this stuff up. And that's going to return this. So I just want to see this in action. So here we are here. The very first thing I'm going to do is we can set up. Man, we'll do that in a minute. Okay, I just want to show this. So we want sphere test. Here it is. Here's our function we just created. We need to pass it the target, which is self, and we need to pass it the agent, which is our controller. We need to figure out what the hits are and all of this stuff, but I sort of don't care right now. I just want this to run and have our debug draw be persistent. So it's just going to draw this every time. So right now, this is our find target. We're going to go back to our behavior tree, AI behavior tree. And in our behavior tree, in our one selector, we are going to say add service. Here's our find target. There it is. So this is our service. Let's pull, come back. Let's pull this guy over here so we can kind of see what's in here. This should look familiar. Look, our sphere distance and our radius, and like we can retune all of this stuff if we want to, because we created it as tuning. This should look pretty familiar based on like the blueprint stuff. And that's kind of it for what we want to do for right now. So I am going to, I wonder if this will run by itself. Let's do this. Let's create a wait task. I think it won't run unless there's a task running under it or something. I've run into issues here. So let's just do this and see if this works. Okay, let's just see what happens. Run. Oh, that's what I wanted to see. That's gorgeous. Okay, well, it's not working how we want, but I knew that that was going to happen. If I eject and come up, you can see what's happening. So let me pull out. There we go. So what you're seeing here is that we have, like, this is the hull. You can see it. It's a combination of the red and the green. this is their radius, that they're not radius, but you know, their visible place. This is what they can see. It's green because it's happily not ignoring probably themselves. Like, I'm not sure why this guy is succeeding, but because he should be ignoring self, although the self may technically be the controller. Anyway, there's a really easy fix for this, which is that we want to, wait, where are we? Here we are. We basically want to do sort of an initialization pass. And, you know, maybe we'll make it another function. So what we want to do with this function is I want to say something like get all actors, here we go, actors of class. We're going to use class. I actually would suggest you use tag. I would tag all the actors you care about. Oh, and I just did tag. I'm going to do get all actors of class because, you know, I'm lazy right now. So we'll do this, and we'll say basically ignore hunters, right? That's what we want to hunt, or that's what we want to ignore. We want to ignore all hunters. And what this is going to do is it's going to say, and we want to fill out this array. So this is actually really simple because I want to do, here, I'll do it here. Well, I'll do set, yeah, let's do it like this. Object to ignore, set. And so we're just going to basically create this array and set it right here. That's the entire purpose of this code, is to set this array. Okay, so that's done. Back here, we don't care about sphere test. So back here, we'll do find all ignored objects, and that's it. So this will start us off. All the ignored objects will be there, and then we'll have this for our hits. And I think this will be better. Yeah, there we go. Eject. Okay. Yeah, this is better. So now we can kind of see a better image of what these spheres look like, and we can tune this stuff. This might be a bit small. I might widen it a little bit, like make it longer so that he can see a little further ahead of him. Red means it has not found anything. Green means it has. So this guy found me. The reason he found me should be pretty clear, because this sort of cluster of red right here, right, this guy here is the player. That's me. So I'm within his radius. So he'll do all the tests, but I'm not in anyone else's radius, right? So you can see that they're not going to test for me. So that's it for this video. We have this basic, like, initial test working. This works well. And, you know, I haven't done this test yet, but, you know, you can see it's still green, and I can pull out of here and it turns red, and then it turns back green when I go back in. So we have this initial test, and then we'll add the vision stuff and so on in future videos. All right, thanks for watching. See you next time.